locomotive, symbol of a powerful industry and a growing country. It moved this nation. Although its purpose has remained unchanged for 165 years, the way it accomplished that purpose has been under continual change. Gradually increasing in size and power, the steam locomotive was king until the 1950s, when diesel-electric technology revolutionized locomotives. Today, new technology is again poised to revolutionize the locomotive: AC traction. During 1996, Conrail will be taking delivery of 28 of Electromotive Division's SD80MAC locomotives. The SD80MAC, or 80MAC, is one of the most powerful and advanced locomotives available today. It is powered by an electronically fuel-injected 5,000 horsepower, 20-cylinder, 2-cycle diesel engine. The locomotive is equipped with an air-conditioned whisper cab, a desktop control stand with integrated cab electronic displays, and electronic air brake equipment. The most notable features of this new locomotive are the self-steering radial trucks and a new proven AC traction system. In this video, we'll show you some of the differences with this locomotive, comparing it with an SD60i. We'll review some important safety considerations and cover the new features, performance characteristics, inspection, and troubleshooting procedures you need to be familiar with. Because of the greater capabilities of this locomotive, there are also some important train handling considerations we need to cover. So, let's take a look. Well, here it is, the latest and greatest from EMD. Aside from the new paint scheme, from this view, it looks pretty much like one of our SD60i locomotives. But let's take a walk to the side and take a look. Now you can see some of the differences. First of all, the SD80MAC is longer than an SD60. The 80MAC is 80 feet long. The SD60 is 72 feet long. The SD80MAC is the largest locomotive in our fleet. Here's another difference. The dynamic brake grids are right behind the cab on the SD60i. They have been moved to the rear of the locomotive on the 80MAC. This allows better airflow to the grids and moves a source of noise away from the crew cab, improving the quietness of the whisper cab. The 80MAC has larger radiators than the SD60 to accommodate the cooling needs of the 20-cylinder diesel engine. The fuel tank on the 80MAC holds 5,800 gallons. The SD60 holds 5,000 gallons. Both number 1 and number 2 main reservoirs are on the right side of the 80MAC, while on the SD60, the number 1 is on the left side and the number 2 is on the right side. Now, here's a major difference between the two locomotives: the trucks. The SD60i is equipped with standard HTC trucks and 40-inch wheels. The SD80MAC is equipped with HTC R2 self-steering radial trucks and 45-inch wheels. One of the most revolutionary features of this new locomotive, this truck design greatly improves weight distribution to the axles. It also allows the front and rear axle to steer when in curves. This reduces wheel flange wear and greatly improves adhesion. Let's take a closer look. Again, we'll use our SD60i comparison to highlight the advanced features of this truck. On the standard HTC trucks found on the SD60, weight is transferred from the locomotive frame to the truck, through the center plate, to the truck bolster, and then to the truck frame and to the axles. Because the weight of the locomotive is concentrated on the center plate, when tractive force is applied to the truck, a weight transfer takes place, much like what happens to your car when you push hard on the accelerator. The front goes up and the back goes down. This tipping of the truck will shift the axle loads putting more weight over the trailing axle and less weight over the leading axle. Since adhesion is directly dependent on weight over the axle, the lead axle is more susceptible to wheel slip than the other axles. This weight transfer is not something you can see on a locomotive truck, but it does take place, and it can cause a wheel slip problem on the lead axle of the truck when high power is applied. Now, let's take a look at the SD80MAC's HTCR2 truck. The HTCR2 doesn't have a center plate or a truck bolster. It's equipped with a center pivot pin, which is used to transfer tractive force and bears no real weight. The weight of the locomotive is transferred directly to the truck frame through 4 rubber compression springs. This spreads the weight more evenly throughout the truck and reduces weight transfer, which greatly improves adhesion. Another important feature of this truck, and a major difference from the SD60i's HTC truck, is the HTCR2's ability to steer or realign its axles in curves. Let's take a look. When an HTC truck enters a curve, because of its rigid axles, a high angle of attack exists between the wheels and the rail of the leading and trailing axles. This high angle of attack causes the wheels to have a greater tendency to slip and also produces greater lateral loading on the rails. When the HTCR2 truck enters a curve, a self-steering mechanism within the truck realigns the leading and trailing axles with the curve. This produces a radial alignment of the axles, which reduces wheel and rail wear and also lowers rolling resistance. Now, here's something that's brand new. An electric motor-driven parking brake. No more handbrake. Mounted on the left side of the front truck is a small DC electric motor. It drives a screw jack that will apply or release the brake shoes on the left number 2 and number 3 wheels. The electric parking brake is operated using a switch located on the engine control panel inside the cab of the locomotive. In the event the locomotive is dead and battery current is not available, the parking brake can be applied manually on the ground by using a cranking tool, which will be stored on the locomotive. Another important feature housed on the trucks is the flange lubrication system. The systems are identical on the SD60 and the SD80MAC. The flange lubrication system is designed to reduce curve resistance, saving fuel and reducing wheel flange and rail wear. This feature, working together with the Radial truck, makes the SD80MAC one of the most fuel-efficient locomotives in our fleet. The HTCR2 truck lacks the center plate, truck bolster, side bearings, pedestals, and pedestal liners found on older HTC trucks, but does have additional components, such as traction rods, steering beams, and steering linkage. These components are readily visible from the ground and should be inspected during the locomotive's daily inspection. Now let's take a look at one of the most important new advances of the SD80MAC, the AC traction system. With modern DC locomotives, like our SD60i, the diesel engine is used to turn the main generator, which is actually an alternator producing AC current. This AC current is rectified, changed from AC to DC, at the main generator. The main generator's DC current output is then fed directly to the DC traction motors. With AC traction systems, we start out the same way. The diesel engine turns the main generator, AC current is rectified to DC. Now here comes the difference. The main generator's DC output is then fed to 2 computer-controlled inverters, one for each truck. The inverters convert the DC current back to AC, which is then fed to the AC traction motors. By controlling the voltage and frequency of the AC current, the inverters control the speed and power of the AC traction motors. Although AC motors have been around for a long time, until just recently, AC motors just couldn't match the starting torque of DC traction motors. Because of this, DC traction motors have been the choice since the early days of the diesel-electric locomotives, right up to our SD60i locomotives. Along with this high starting torque, DC motors brought along many limitations. DC traction motors are equipped with commutators and carbon brushes, which are subjected to very high current loads. Applying high current loads to a DC motor that is not turning or turning very slowly can cause severe damage to the commutator and the brushes if the high current is applied for too long a period of time. At the upper end of the locomotive's amp range, this can be just minutes. This is referred to as the short time ratings for the locomotive's traction motors. AC motors are not equipped with commutators and brushes, so AC traction motors do not have this limitation. That means no short time ratings. And now, because of advances in computer and inverter technology, the starting torque of the SD80MAC AC traction motors actually exceeds its older DC counterparts. The nature of these AC traction motors also makes them less susceptible to wheel slip. DC traction motors also require high current levels or amps to produce high power. Heavy traction motor leads and conductors must be used to carry that high current, and the high current also produces a great deal of heat, which further limits the DC traction motor. The SD80MAC AC traction motors rely more on the frequency of the alternating current to produce power. For that reason, you will not find an ammeter on the control stand display. Instead, the locomotive's computer system calculates and displays tractive effort in pounds on the cab display for each AC locomotive. Tractive effort is the actual force the locomotive, less its own rolling resistance, exerts at its coupler. Now the engineer can get an actual indication of how much pulling power he is applying to the train. This is a great feature. Let's go up and take a look in the engine room. But before we do that, there are some important safety considerations with AC locomotives we need to review. Unlike the high voltage circuits found on conventional DC locomotives, the AC traction system found on the SD80MAC and all AC locomotives requires components to store energy in the form of high voltage. These high voltage circuit components are referred to as DC-link capacitors and are capable of storing a charge of 3600 volts DC. This high voltage can be present in the high voltage or traction control cabinet of the locomotive even when the locomotive is shut down. The high voltage traction control cabinet on the SD80MAC is located just behind the cab with access from the running boards. Only qualified maintenance personnel are allowed to access this area of the locomotive. For the purpose of protecting personnel and equipment, this locomotive is equipped with 3 automatic discharge systems which will reduce DC-link capacitor voltage to 0. The first system functions whenever the reverser handle is moved into the neutral position. Bleeder resistors will bleed off the capacitors to 0 volts. The second system will discharge the capacitors through the dynamic brake resistor grids anytime the isolation switch is placed in the isolate position. The battery switch must be closed and battery voltage must be present for this to take place. The third system will discharge the capacitors whenever the diesel engine shuts down. When the diesel engine shuts down, the auxiliary generator ceases to produce output. The inverters require auxiliary generator output to function properly. So when auxiliary generator output is lost, the inverter triggers a protective electrical crowbar. This electrical crowbar creates what is essentially a direct short circuit across the capacitors, which discharges them instantly. To be certain that the automatic discharge methods have functioned properly, a system self-test can be executed using the control stand display. If the self-test determines that voltage has not been removed, the user will be notified by computer display messages and the sounding of an alarm. Let's go take a look in the engine room. We'll start on the left side, work around the locomotive, and then right up into the cab. Just behind the cab is the high voltage traction control cabinet. This is where the capacitors, inverters, and high voltage switchgear are housed. Again, only qualified maintenance personnel are authorized to access this area of the locomotive. Moving back, in this area, the main generator, turbocharger, and turbocharger aftercoolers are located. This is referred to as the generator end of the diesel engine. The main generator is connected directly to the crankshaft of the diesel engine, which is housed in this area of the locomotive. This 20-cylinder, 2-cycle, 710 diesel engine is the heart of this powerful locomotive, pumping out 5,000 horsepower. The basic construction of this diesel engine is the same as you would find on all EMD locomotives. On the top of the diesel engine is the exhaust manifold. Below that is the top deck area, the cylinder test cocks, airbox covers, and crankcase covers. And of course, the lube oil dipstick for checking the lube oil level of the diesel engine. Moving back, we are now at the accessory or free end of the diesel engine. This is where the water pumps, oil pump, and electronic fuel injection components are located. Notice there is no governor. It has been replaced by the electronic fuel injection components. Engine water fill and the water level gauge are accessible from this area. Further back is the water expansion tank, the fuel oil filters, and below the fuel pump and lube oil filters. These next doors access the AC cabinet, which houses the electrical components for the electric motor-driven equipment and traction motor blowers, the radiator fans, and the electric motor-driven air compressor. This cabinet contains high voltage. This area at the rear of the locomotive is where the dynamic brake grids are located. Moving around to the right side of the locomotive, these doors access the electrically driven 4-cylinder air compressor. Inside, there's a dipstick to check air compressor oil level that should be checked whenever the diesel engine lube oil is checked. Behind the next doors, the lube oil cooler is located, as well as the air supply cutout cocks for the horn, split cooling system valve, and the air start magnet valves. And now we are at the right side of the accessory or free end of the diesel engine. Here you will find the crankcase pressure reset. This is the only manually operated reset found in the engine room. Other diesel engine protective devices are reset automatically or can be reset using the display on the engineer's control stand. These include protective devices such as engine overspeed, low water pressure, and low oil pressure devices. Like all other EMD locomotives, the engine water fill, water level gauge, and main water drains are accessible from this area. Further up, we have all the same components we saw on the left side. And now here's something you won't find on other EMDs, the air start motors. Because of the size of this diesel engine, the electric starting motors may need a little help turning over the engine during starts. 2 air-operated motors provide that help. You need about 80 psi of main reservoir pressure to operate these motors. Eventually, EMD plans to replace this system with one that utilizes the companion alternator to start the diesel engine. That's all there is to see out here. Let's go up into the cab and take a look around. At first glance, you might not notice any difference from our SD60i locomotives. Everything is laid out the same. Controls, seating. Let's take a look at the displays. You may have seen these before. This is the new AAR screen format. It's a little different from what you may be used to. There are 2 displays, the operations display and the setup menu display. The operations display contains all the information you need to operate your train, such as speed, power, amperage or tractive effort, and air brake information. The setup menu display can be used for setting up the electronic air brake components, setting up your EOT code, or setting up and using the slow speed control system. Or it can be used for diagnostic information and reset functions. When the screen select switch is set in the both position, the right screen will show the operations display and the left screen will show the setup menu display. In the event of a screen failure, the switch can be used to move the operations display to the right or left screen, in which case the functions and data of both displays will be combined into one. Let's take a closer look at the operations display. Located in the top center portion of the screen, you'll find speed and a graph that shows your rate of acceleration or deceleration. The top left portion of the screen is air brake information, such as brake cylinder, main reservoir, airflow, rear brake pipe pressure, equalizing reservoir pressure, and brake pipe. The top right portion of the screen is information on power or dynamic brake amperage or tractive effort on the SD80MAC. Throttle or dynamic brake handle position and reverser position is also shown. The next area down is for the indicator lights, such as wheel slip, PCS, alerter and air brake fail. The next section of the screen is for locomotive status, air brake status, and crew messages. The very bottom of the screen is the menu for the function keys, or the buttons. The setup menu display normally shows a menu for set EOT ident code, set slow speed control, change air brake setup, and select additional menu items, which can be selected by using the function keys below the item you wish to select. Locomotive status, diagnostic information, and reset functions can also be handled through this display. Let's take a closer look at the rest of the control stand. The layout is similar to the SD60i's control stand. However, some of the switches have been moved for easier reach. The throttle dynamic brake controller and the air brake controller have also been moved a little closer to the engineer. On the left-hand side of the control stand, referred to as the control and switch panel, you'll find the engine run switch, generator field switch, control and fuel pump switch, dynamic brake control circuit breaker, headlight switches, screen select switch, and the ditch light on-off switch. There is a built-in clipboard for your orders. The horn, bell, and sand switches are located in the center area of the control stand, to the left of the reverser throttle dynamic brake controller. On the right-hand side of the control stand is the air brake controller for the Epic 3102 brake equipment. This equipment is identical to the EPIC equipment found on our SD60Is, and its setup, cut in, cut out, and operations procedures are also the same. Let's go take a look at the engine control panel. On the engine control panel, you'll find headlight control switch, the isolation switch, EFCO or the emergency fuel cutout switch, dynamic brake cutout switch, number light and marker light switches. New to this panel is a device that allows the EFCO button to be locked in to prevent the diesel engine from being started during certain maintenance procedures. The engine start switch is now also located on the engine control panel. Remember we mentioned earlier the electric parking brake? Well, this is the control switch used to apply and release that parking brake. It's very simple to operate. To apply the parking brake, first rotate the outer ring of the switch to the right to the apply position. Then push and hold the center button until the parking brake ammeter increases to the yellow applied zone, indicating that the electric motor has stalled and that the brake is fully applied. This takes about 60 seconds. To release the brake, follow the same procedure. First, rotate the outer ring to the left to the release position, then push and hold the center button until the ammeter moves to the blue release zone. This indicates that the brake has been released. Remember to follow the instructions in your EC99 for visually observing that the brake has been fully applied or fully released. To the left of the engine control panel is the circuit breaker cabinet. Inside, you'll find the battery switch and all the same circuit breakers found on the SD60, plus several associated with the AC traction system, the electronic fuel injection, and the electric parking brake. Just as with all EMDs, all circuit breakers in the black area must be on for the locomotive to operate. This locomotive is also equipped with a 400 amp start fuse. However, this fuse has been relocated to a cabinet just above the fuel tank on the left side of the locomotive. Eventually, this is where the inverter equipment will be located for EMD's new main generator start system. Let's take a look at a few of these circuit breakers. Wheel flange rail lube can be used to disable the flange lube system for 15 minutes and to reset the system. ABICO, air brake in cutout, prevents dropping out of the air brake system computer due to low battery voltage when starting. This is a reset breaker only. Cab display computer, sometimes labeled ICE. This breaker protects the ICE computer and cab displays. Air brake. This is the power supply breaker for the EPIC air brake system. TCC1 comp protects the traction inverter number 1 computer. TCC2 comp protects the traction inverter number 2 computer. Turbo must be on to operate the turbo auxiliary oil pump immediately after engine startup and shutdown. Do not turn this breaker off. Computer control. Power supply for the locomotive control computer. All the diesel engine systems are tied in with this computer. Do not turn this breaker off. Ground relay cutout switch. Disables ground relay protection on the locomotive. Only authorized maintenance personnel may operate this switch when performing tests. Parking brake. Power supply for the electric parking brake. Now that we've covered some of the new components and features of this locomotive, let's talk about operation of the SD80MAC. We've already covered the operation of the electric parking brake. But what if the locomotive is shut down? Well, as long as the batteries are okay, just make sure the parking brake circuit breaker is on, and then just operate the parking brake switch. But what if the batteries are dead? Well, use the crank. Let's go down and take a look. To apply the parking brake manually, first, make sure the parking brake circuit breaker is off. Then, simply remove the crank from its storage holder, insert the crank in the socket, and crank away. The crank is turned clockwise to apply and counterclockwise to release. The crank is very easy to turn, but it does take a lot of turns of the crank to fully apply or release. Make sure you crank the handle as far as it will go, and then return the crank to its storage holder. Next, engine start procedures. Except for checking the 400 amp start fuse, which is outside on the left side of the locomotive, and checking the crankcase pressure reset device, engine starting procedures are handled entirely inside the cab. First, check the controls. Make sure the reverser is in neutral and removed. On the control stand, make sure the generator field switch is off, engine run switch is off, and the control and fuel pump switch is on. Next, check the isolation switch on the engine control panel. Make sure it's in the start, stop, isolate position. Then, in the switch and circuit breaker cabinet, close the battery knife switch. Make sure the ground relay cutout switch is closed and that the auxiliary generator circuit breaker is on. Turn on all the circuit breakers in the black area, as well as the turbo and computer control circuit breakers. Then, place the fuel injection switch in the run position. Now you're ready to start the engine. Push the engine start button and hold for about 2 to 3 seconds. The locomotive's computer will automatically prime the fuel system. Then, it will sound an alarm in the engine room to warn that a cranking cycle is about to take place. The engine's dual electric starting motors will start the purge cycle and crank over very slowly for about 6 seconds. Then, 2 air motors engage the flywheel to bring cranking speed up quickly. All this with just the push of a button. If, after pushing the engine start button, you wish to abort the engine start, you must push the emergency fuel cutoff button, the EFCO. The diesel engine may be started with just the electric motors alone if there is insufficient main reservoir pressure, less than 80 psi, or with the air motors alone if the batteries are weak. Coupling the locomotive's main reservoir equalizing line to another locomotive's main reservoir equalizing line would provide the necessary main reservoir pressure. Oh, and don't forget, if the engine has been shut down for an extended period of time and the engine block is cold, you should open up all the cylinder test cocks and crank the engine over a revolution or two to clear out any fluid that may have accumulated in the cylinders. On the SD80MAC, you must leave the fuel injection switch in the off position when doing this procedure. Once the battery knife switch is closed and all the circuit breakers in the black area are turned on, including the cab signal, cab display computer, and air brake circuit breakers, the ICE display screens on the control stand should come up. If they don't, check the cab display computer switch or ICE circuit breaker and reset if necessary. And make sure the display select switch on the control stand is in the bolt position. With the screens up, now we're ready to check our air brake setup. Anytime the EPIC air brake system is powered down or de-energized, an alarm will sound, the brake fail will light, the air brake system will automatically go to trail, and the pneumatic backup system takes over. However, the computer holds in memory the last air brake setup that was in effect prior to powering down. When the system is powered up, the screen will show the last air brake setup. The data fields of the air brake portion of the screen may show asterisks until the computers have gone through their startup tests and have detected the status of the air brake system. Whenever the system is powered down or powered up, EPIC will cause a penalty brake application to occur. If the last air brake setup was lead cut in, when the system is powered up, you will receive a message on the screen to place the automatic brake handle in suppression to recover. If the last air brake setup was trail, you will have to set the system up for lead before you can recover from the penalty. Let's set this locomotive up for lead. This procedure is exactly the same as with our SD60Is. Let's go through it as a review. First, make sure the independent brake handle is in the full application position, and the automatic brake handle is in the release position. Then, press air brake setup. Then, lead trail for lead. Then, accept new. The system will ask you to confirm the setup by pressing accept new again. Equalizing reservoir pressure will increase, and the independent brake is now cut in. Next, we'll cut in the automatic brake by pressing air brake setup, then cut in, cut out for cut in. Accept new and accept new. If equalizing reservoir pressure must be adjusted, press air brake, then EQ res setup. Use the preset keys or the increase-decrease keys to set the pressure. Then press enter and accept new and accept new. The air brakes are now properly set up, and after performing the appropriate tests, we're ready to go. Okay, now let's talk about some of the operating characteristics of this powerful locomotive. Don't worry, the basic principles of train handling will not change with the introduction of the SD80MAC. Although there are some operating characteristics particular to AC locomotives that you will need to be familiar with. Let's talk about some of those characteristics. First off, the SD80MAC has greater capabilities than anything you've ever handled, especially below 10 miles per hour. The 80MAC produces 5,000 horsepower and 185,000 pounds of starting tractive effort. The best our most powerful DC locomotives can achieve is 108,000 pounds of tractive effort, and that's at 11 miles per hour. Below that speed, higher tractive effort is possible. However, the thermal limits or short time ratings of the DC traction motors and higher wheel slip potential limit the amount of TE you can actually apply. The SD80MAC's AC traction system, along with a very aggressive wheel creep system, allows it to achieve much higher adhesion levels than DC locomotives, 45% versus 27%. So, wheel slip indications seldom occur. And since the AC traction motors do not have any short time ratings, the 80MAC can provide that 185,000 pounds of tractive effort all day long. The sound and feel of the 80MAC's wheel creep system at work may take some getting used to. At low speeds under heavy load, the aggressiveness of this wheel slip system with its feel and sounds may cause you to want to notch back the throttle. But unless you're getting a wheel slip indication, don't. Let the locomotive do what it does best. Provide very high power at very low speeds. The 80MAC's dynamic brake is the most powerful of any locomotive available today. It can produce up to 96,000 pounds of braking force, 35% more than an SD60, right down to 1/2 mile per hour. Remember to be very careful with the dynamic brake at low speeds while in sharp curves and turnouts. Each SD80MAC is equivalent to 9 axles of extended range dynamic braking. Another operating characteristic that may require some adjustments is the way the 80MAC loads up. It loads slower than you might be used to with other EMD locomotives, and it displays its loading in tractive effort, not amps. Because of the slower loading, It is recommended that you advance the throttle to what you think you will need to start the train before you release the independent brake. It is not recommended that you jockey the throttle back and forth from idle to notch 1 to start the train. Just release the independent slowly with the throttle advanced to where you need it, and let the locomotive take the train out nice and easy. You must keep the slow loading characteristics in mind when starting a train on an uphill grade. Make sure you've advanced the throttle high enough to prevent the train from rolling back before you release the brakes. You may even need to use a notch or two more than you normally would with DC locomotives in this situation, because if the train begins to roll backward and gets up to 1.5 miles per hour or higher in the wrong direction, you'll lose the load and the locomotive's computer will command full dynamic brake until the train stops. Then you'll have to start all over again using a higher throttle setting. Here's another operating characteristic particular to AC locomotives. AC traction motors can't be plugged. If the reverser is moved to a direction opposite to the direction of travel, the locomotive's computer will command full dynamic braking until the reverser is moved out of the wrong position or the locomotive is stopped. The SD80MAC has been tested extensively at the AAR's test track at Pueblo, Colorado. Let's see what the AAR test engineer has to say about this locomotive.
My name is Mark Woodworth. I'm a locomotive engineer at the Transportation Technology Center in Pueblo, Colorado. I've been affiliated with MAC 80 locomotives since it arrived here in July of 1995, and been operating it with EMD personnel doing the preliminary test work on this locomotive. Conrail people are going to be receiving these locomotives, and I'm excited about AC power. And this engine has a feature, it's called wheel creep, and it's computer controlled. If you're pulling a steep grade, you're going to feel wheel creep activate. You're going to feel the engine start to move and jump a little bit, and you're going to want to come off the throttle. I'll guarantee it, because I did when I first started running it. Let the engine do its own thing. Since I've been running this engine for as long as I have a lot more confidence with this engine than I do with the DC unit, because of all the capabilities that it has over a DC unit. One of the features that you're going to find that's really nice is the dynamic brake feature. You will keep full dynamic brake feature down to a half a mile an hour, which, as you know, in the past you didn't have that feature with DC units. Plus, even at a half a mile an hour, your dynamic brakes are just going to fade off slowly. Comfort cab on these units are a lot quieter. They've done noise level test on them, and I can talk to you comfortably in throttle 8. I really like these cabs. Are a really nice feature. Just give yourself a little bit of time, get used to them a little bit, and I think that you'll really like them.
As you've seen, computers enhance every function of this locomotive, from controlling and monitoring the AC traction system and the diesel engine systems to controlling the operation of the air brakes. Troubleshooting any locomotive problem is also enhanced by the locomotive's computers. Most mechanical and electrical faults can now be handled right at the engineer's control stand using the computer displays. The locomotive's computers are capable of displaying over 1,000 different crew messages about locomotive conditions and faults. For some conditions or faults, the display provides information only. Other conditions or faults may provide the information with the option to reset the fault manually through the display keys, or the fault may be reset automatically by the computers. Locomotive operation may be unaffected. It may be automatically reduced or restricted, or it may be shut down. All the information you will need will be provided on the display, including what you may need to do to reset the fault manually. Let's take a look at a few crew messages. The crew message screen displays information on the fault in this area of the display. A menu of options is displayed in this area. A blue line extends to the button that activates that menu item. The light blue bar highlights the items that are active. Other menu choices can be made available by using the Shift key. In addition to providing high voltage ground protection, ground relay, the locomotive will protect electrical components during a fault by firing an electrical crowbar. Crowbar is a new term used to describe an action that removes power from the electrical components. This action is the same as with ground relays, something you're already familiar with. These are serious faults that require reporting. Just like with ground relay protection, the locomotive will reset most crowbars automatically. But if the locomotive fires 2 or more crowbars for the same fault in a short period of time, it will drop out locomotive loading and lock out the electrical system. In this case, the crowbar will have to be manually reset using the display. If the fault that caused the crowbar occurred with one of the 2 inverters, it may be necessary for you to cut out or disable the problem inverter. Let's take a look. When the fault occurs, the locomotive will immediately display it on the setup menu display. As soon as it's safe to do so, the engineer can cut out or disable the inverter and reset the crowbar. With one inverter disabled, the locomotive will still produce about 55% of its power. Here's something that's very important to keep in mind. These locomotives produce a tremendous amount of pulling power. If a crowbar is fired under full load at low speed, the sudden removal of power can cause a pretty good jolt in the cab. The lower the speed, the more severe the jolt can be. So, for safety, at very low speeds under full load, it's a good idea for cab occupants to remain seated. If it is necessary to stand or move about the cab, make sure you maintain a secure handhold. Well, that's it. Here it comes. The safest, most comfortable, and most powerful locomotive available today. Just keep in mind some of those safety considerations and operating characteristics that we've talked about. And then handle this locomotive like you would any high horsepower locomotive. Now it's up to you to get the most out of the SD80MAC. Thanks for watching.